Hello everyone and welcome to today's webinar, Lubricant Fundamentals 201 Lubricant Composition, brought to you by Cbm Connect. I'm Paige Hattie, the manager of Cbm Connect, and I'll be your moderator for this session. So before we get started here today, I'd just like to review some important information with you. This webinar is being recorded and you'll be emailed a link with access to the on-demand version of this webinar tomorrow. The recording of the webinar will also be posted to Cbm Connect, so feel free to share it with your colleagues if they weren't able to join us here today. So Mobius Institute is a worldwide provider of reliability improvement, condition monitoring, and precision maintenance education to industrial plant managers, reliability engineers, and condition monitoring specialists, allowing plants to be more successful in implementing reliability improvement and condition monitoring programs. Mobius delivers training via public in-plant and online education programs, and Mobius's key advantage is its unique training style that uses innovative 3D animations and software simulations, making complex topics easier for you to understand. More than 38,000 industrial professionals from over 160 countries have been classroom trained since 2005, and thousands more through our e-learning products as well. The Mobius Institute Board of Certification is an ISO-accredited certification body that provides globally recognized certification to reliability professionals, vibration analysts, ultrasound analysts, and thermal imaging specialists. So then next up, if you've been looking to further your education in person, be sure to check out the Cbm Connect conference, co-located with Reliability Connect, for hands-on presentations and a variety of condition monitoring and reliability improvement topics. And when we say hands-on, we mean it. You'll be able to get your hands on test rigs, analyzers, and other tools and instruments as well. The Cbm Connect conference, co-located with Reliability Connect, hosts 9 training events annually in Australia, China, Europe, Malaysia, Mexico, the Middle East, South Africa, the UK, and the USA. And the next conference is coming up in South Africa, the 10th through the 12th of March. And then as a thank you for attending this webinar, Cbm Connect would like to offer you and anyone at your facility a special conference rate. When registering for any event, you can enter code Mobius Connect to save $100. Again, that's code Mobius Connect. You can find further information or register for the conference at thecbmconference.com. And then next up, we have Cbm Connect, which is the premier condition monitoring online educational community published by thought leaders and experienced industry professionals from all over the world with a dedicated focus on all of the condition monitoring technologies. Cbm Connect allows you to customize your profile to see new content each week in condition monitoring management, alignment and balancing, lubrication, motor testing, oil analysis, thermography, ultrasound, or vibration analysis. You can get started on Cbm Connect by creating your free profile and selecting which technologies you'd like to learn more about today. And you can visit cbmconnect.com to get started. And then furthermore, if you're interested in contributing or becoming more involved with Cbm Connect, please reach out to us during the webinar through the question panel, and we'll be happy to share more information with you. So for those of you just joining us, welcome to Lubricant Fundamentals 201, Lubricant Composition, presented by Lubrication Engineers. So if anyone has any questions throughout the webinar, go ahead and type them in the question panel of your GoToWebinar screen, and we'll be sure to reach out to you after the webinar is completed here today to make sure that your questions have indeed been answered. All right, so let's go ahead and get the presentation started.
Good afternoon to everyone. My name is Scott Leipprandt with Lubrication Engineers, and today's topic is lubrication fundamentals. We're going to talk a little bit about the fluids, what's in the fluids as far as composition, some of the different base stocks and additives that go into the fluid, grease composition, which is very similar to the fluids, but it also has a thickener in it, and a little bit about the different types of greases. So let's jump right in. What is a lubricant? We think of lubricants as primarily being oils and greases, but the purpose of them is the same. And a lubricant is just that substance that reduces the friction between two surfaces when they rub together. What is a lubricant composed of? As I mentioned, it's composed of base stocks and additives. They're typically blended, heated, there's agitation, there's various steps in there. But when it comes out, that's what goes into a finished lubricant. I'm going to touch briefly on base stocks, but what do we mean by base stocks and where do they come from? We all pretty much have heard about crude oil and the price of crude oil and stuff, but the amount of lubricant that is used in a base stock is pretty small. It's about a half a gallon of a 42-gallon container is really the base stock that we use for lubricant. The primary purpose of it is, of course, to get gasoline in the process, but it's also where you get the diesel and the kerosenes, and you can see other things that come out as byproducts of the petroleum refining. Base stocks qualities vary a great deal. It depends on where the crude oil came from, as well as the refining process that it went through, as well as there's individual unique aspects to different refineries. So based on that, you can have different viscosities that come out. The oxidation stability among various base stocks vary. Oxidation stability is a very important attribute in most lubricants. The volatility, the flash point varies. The appearance varies. I mean, particularly in our fluids, we like to have a nice, clear clarity that goes through. There can be some consistency from batch to batch if you're not careful watching it. Obviously, you want to be well aware of any toxicity, but normally by the time we get a refined base stock, we're not worried about it. The solvency can vary from base stock to base stock, and this has to do with how the base stock's ability to keep those additives in suspension. Primarily, we think of base stocks as being in three main categories. We've talked about the mineral oil, and I think that's the one that we're mostly familiar with. Just know that even though it's a mineral oil, the types of mineral oils that come out of there, depending on how they're refined, can be different. They can be a paraffinic, a naphthenic, or an aromatic. We're going to talk about paraffinics and naphthenics a little bit more. Synthetics are also base stocks, and those are becoming more and more popular. They each have unique pros and cons to them. Some of the ones that we think of most commonly are PAOs, polyalpha olefins, diesters, polyol esters, phosphate esters. And then, although we don't traditionally hadn't thought about base stock, vegetable oils are starting to be used more as base stock. This is the oil from the seeds, whether it's canola, soybean, sunflower, or corn. They're squeezing the oil out of there, and that's being used for some lubricants today. API, the American Petroleum Institute, breaks the base oils into different classifications. We're not going to spend a lot of time on this today, but if you spent much time in the industry, you've probably heard about Group 1, Group 2, and Group 3 oils, and then the other ones. And we want to touch on them briefly. Group 1, Group 2, and Group 3 are all mineral-based oil. And the difference between them, in the simple term, I'm going to say, is the amount of processing or refining that they go through. So a Group 1 has is less refined than a Group 3, where we call it severe hydroprocessing. And that changes the oil a great deal, strips away a lot of the sulfur and some of the other things. But at their core, all three of those start as mineral oils. Group 4 is where we put polyalpha olefins. It's the only Group 4 oil is a polyalpha olefin. It's the only oil in that classification. And Group 5 is by default where everything else falls. So if it's doesn't fall into a category 1 through 4, by definition, it's a Group 5. Let's look at some of the base stocks and some of the where they're used and where they come from. As I mentioned, Group 1 is solvent refining. They call it solvent freezing here. It's the least refined oil. It's a mix of different hydrocarbon chains with little or no uniformity. It sounds horrible, but that's not necessarily the case. It's just has more of a different variety of hydrocarbon chains in there. There are applications where Group 1 oil actually has some benefit over the others where you want some of it. It is very limited in automotive oils and things of that nature. Realize that automotive oils make up more than half of the overall lubricant market. So that's what drives a lot of the changes. Group 2 are much more common. That is where a majority of the engine oils today are still made from Group 2 oils. It's got pretty good performance in volatility and oxidation stability, and it has fair performance as far as the pour point and the cold crank and EP. Obviously, we'll look at when you make an engine oil from a Group 2, you take care of all the deficiencies and enhance certain abilities with the addition of additives. Group 3, as we talked about, is very highly refined. It is the highest level of any mineral oil that the refining process. It goes through more than any of the other ones. It's not a chemically engineered product like a synthetic, but it is so highly refined. Look at this third bullet. It's so highly refined that it is frequently marketed as a synthetic or as a semi-synthetic, and that's not illegal. That was a decision made by the courts that this is such a highly refined oil that it can be called synthetic, and indeed it has some of the same carbon chains, and there's a lot of similarities to it with it, and particularly the polyalpha olefin. And the Group 3s are very common in the States these days, and they're going to be growing, particularly in the use of engine oils and stuff like that. We'll see more and more of those on the market. Group 4, as we talked about earlier, is polyalpha olefin. That is a synthetic base stock combined with different additives. It gives outstanding performance over a wide range of lubricating products. And Group 5, as you know, that's where everything else falls. Just a little bit of the base oils and what some of the differences are. Let's take a little bit more in-depth look at the mineral base oil stock. As I alluded to, the sizes of the carbons, there's a lot of different sizes and of the molecules in there. And it also has a fair amount of contamination in there as far as the sulfur and the wax and solid and water and everything that comes out. And the purpose of this refining process, and we're not going to go through the refining process today, but it's remove those impurities through a variety of different processes. This is to make the chemist in the group a little bit happier. These are the things that we talked about them being uniform and getting rid of some of the different non-regular molecules to give us a more uniform base stock. And that's what some of these molecules look like. The two most common types of mineral oil are paraffinic base oils and naphthenic. Paraffinic base oils are typically defined as having a higher VI. When you think about them having a viscosity index in that 95 to 100 range, most mineral oils, many products are made from a paraffinic base stock. Naphthenic are not used as much today as they have been in the past in most plant applications. Where naphthenic base oils are used is on locomotive engines. The engine oil for locomotives is still a naphthenic-based oil. Refrigeration oils. Naphthenic oils have very low pour points and cloud points, so they're used on some refrigeration oils, and some are still being used as compressor fluids. A lot of those are being switched from a naphthenic to a synthetic now. But over here on the left, when you look at the applications for the paraffinic oils, you'll see That's what we think of when we think of crankcase oils, engine oils, if you will, hydraulic oils, turbine oils, if any of you here are out of the power industry, gear oils, bearing oils, all those are part of the paraffinic base oil. That's what's used as a base stock. A little bit about the synthetic base stock. The summary of it is, as we said, they are man-made, they're controlled, and they produce a desirable base oil advantage. Base stocks are designed with the goal in mind, and the processes that they run through are to achieve that goal. We talked on, there's a lot of different types of synthetic base stocks, but typically some of the benefits of synthetic base oil is it has a high viscosity index. It can have good thermal stability or oxidation stability. Going to go with cost, and we'll look at some of the costs relative to one another, but it goes up. The cost of synthetics is naturally higher, and some problems with seal compatibilities, particularly the PAOs and stuff. That most seals, when they were when PAOs and synthetics were being introduced, were designed to be optimal for use with mineral oils. There are seals that work fine with the synthetics, but you need to pay attention to that. So both of these fluids, mineral and synthetics, require the proper selection of additives to provide a premier product. The benefit of a synthetic base stock, as you would imagine, because we've set it up to make that, it's very consistent in the molecule size, very repeatable structure, so it's a very clean process, very pure outcome that we get together. So it makes for a very good base stock for many applications. Some of the areas where synthetic base stocks are used, some of them are almost required, like in jets, right? I think most of you are aware of the extreme temperatures that a jet can operate, right? It can be sitting on a runway in DFW and it's 110 or Phoenix, very high. And when you get up at altitude, it's sub-zero, right? So you need a lubricant that can go over a wide temperature range, which sets up nicely with a high DI index that we talked about on the synthetics. And also, and I'm sure we're all pleased, when for jets, you want a lubricant that's fire retardant. I think most of you know that oil, remember the refining process, gasoline and diesel fluid are part of the refining process. Well, oil can be burnt, right? So that's one of the requirements, and that's why jets use synthetic. Some of the other benefits are it's good oxidation stability. We talked about the thermal stability. We certainly touched on and need to emphasize that they typically have a higher viscosity index, can lead to lower friction, less wear among the parts, can have a higher flash point, and can have a lower pour point. So all those two things are both good attributes to have. Because it's a very uniform molecule, it has very high shear strength. There's some that have natural detergency, and we touched on that it can operate over a wide temperature range. Some of the disadvantages of synthetic base stocks, we starting at the top. We talked a little bit about the cost. If you have to dispose of it, depending on the base stock, there can be costs associated with that. There may be concern with toxicity that you may have to take into account. They're not real stable in water, so the hydrolytic stability in many synthetics is not as good, where water can cause continued either a breakdown of the fluid or a detrimental effect to it. Water in a mineral oil certainly isn't a great thing, but normally it's not such a quantum change as it might be with certain synthetics. Seal compatibility we touched on, and the mixability. We'll talk a little bit about compatibility, but not all synthetics are compatible with other synthetics. Not all synthetics are compatible with mineral oils. So you have to pay a little bit more attention when you're changing or getting a complete, when you do a changeover, maybe getting a complete flush, and making sure that you don't put two incompatible fluids in the same sump simultaneously. The different types of synthetic base stocks we've touched on: PAOs, diesters, polyol-esters, PAGs, polyalkyl glycols, and silicones are some of the more common ones that we use. This little chart gives us an overview of the different synthetics and some of the pros and cons of each of the synthetics in certain areas. So let's start with a polyalcohol. And we're going to set its cost as a moderate cost, just to have a place to start. It's very good corrosion, oxidation stability. It gives you a good viscosity range, very good flash point, pour point, temperature range. It's not so good with additive solubility, and it's not so good with biodegradability. Excuse me. And I don't know that it's shown here, it may be on another slide, but PAOs, certain PAOs are not necessarily great with seals, but they can be compensated so they're not as detrimental to seals. So looking at that and comparing it to a silicone or one of them over there, these are very expensive. Fluorocarbons, silicones, we typically think of those in very high temperature applications. They're much more costly. We're not going to go through everything, but it's here so that you begin to appreciate, like anything, there's pros and cons. There's some synthetics that do well in certain areas, not as well as others. And so when we're making lubricants, we try in selecting the base stock, we kind of think about the application, what's needed for that application, and we design from there. Vegetable is another base stock that we looked at. We talked about the different types of seeds that are used for it. Note that vegetable oil is currently about 2% of the worldwide consumption, but they think that that it's going to increase over time, and I believe that it will also. It's not as increasing as quickly as people thought initially, but we will see the demand for these types of base stocks in the future. The benefits of the vegetable base stock using it is really summed up in those first two bullets. It's non-toxic and it's biodegradable. And as we all try to become more green, that's the balance that we're trying to do. No one wants to use toxic or something that's not biodegradable, but you have to balance that against the application and what is needed to take care of the application. So those are the two main benefits of a vegetable oil. The disadvantage of them is the oxidation resistance, for one, is very poor. It just doesn't hold up under temperature the way a mineral oil, a paraffinic base oil, like would in a similar product. So the other thing is additive biodegradability. So, it's wonderful to have a base fluid that's biodegradable, but the technology isn't there on the additive side today, for the most part, to have the same performance, price, and I touched on it, performance. I think that kind of summarizes some of the concerns I would have point out that need to be taken into account for vegetable oils. Vegetable oils versus food grade. Vegetable oils do comply with food regulations. They are inert, they're tasteless and odorless. They're internationally approved and accepted, but they must meet the general technical requirements as far as reducing the friction and wear, protecting against the corrosion, dissipating the heat, and not having a negative effect on the seals. Talking about food grade lubricants, let's look at the definition. Typically, NFF does the rating now. Note that on the right, that it's NFF that does that. And they followed the same categories that the USDA set up a great many number of years ago. And H1 lubricants are used where there's a potential of an incidental contact with food. There's certainly regulations of how much can get in there. It's not the intention that this lubricant can enter into the food, but if it comes in contact in limited amount, that's understood. And a place to think about that is conveyors and different things when we have an H1 product, the belt's riding on top of the lubricant, but it's possible for a little bit of the lubricant to get on the belt and perhaps be transferred somewhere. That's deemed acceptable if you're using an H1 lubricant. H2 lubricants are those lubricants that do not want to come into contact with the food. So the rule of thumb used to be that they were used below that belt, below that processing line, so there was no potential for incidental contact. Many food manufacturers today are requiring H1 products only to be let into their plant, no H2, because they don't want to even have the potential of somebody using the wrong lubricant and having it touch the food. H3 is a category for lubricants that are edible, vegetable oils and things of that, where they're designed to come into contact with the oil. On the industry side, we use them, for meat hooks. I've seen them when they, lubricate needles, various things that are being done with the food grade industry. So then, as we talked about the lubricant composition, we've talked a little bit about the base stocks. Now we're going to talk a little bit about the additives that go into it. There's a great number of additives that are used by them, and they fall into different categories in general. That we have additives that depending, remember how we looked at the base stocks and they all have different characteristics or properties. But if we want to enhance the antioxidants or enhance the ability for it to foam, or enhance the ability for it to separate with water, or enhance its corrosion inhibitors, we have additives for that. There's also some undesirable base oil properties, low viscosity index. And viscosity index is just the measurement of how much the viscosity of the fluid changes relative to a change in temperature. So remember we talked a little bit about an airline, and he goes from, a positive 120 F, or the operating temperature is certainly above that, up to when it's up at altitude, it's -0 or -30 F or below. Well, you want to have the viscosity of the fluid to be similar to that entire temperature range. So you want a high viscosity fluid. So that is why we use viscosity improvers sometimes, because if we're going to use a mineral oil, they're more cost effective, we can improve the performance of that with a viscosity index improver. And there's certain properties that we want to add to the oils that the oils don't typically have. And these have to do with primarily with the wear, but also some detergency. In general, in a finished fluid, the additive is somewhere 70. The base oil is 70% or more. There's very few that have 30% additive. 15 to 18% additive is pretty heavily additized, but the balance of it is then made up with the additive. So a finished lubricant is primarily the base stock, so that's why the base stock selection is important, but know that the amount of additives in each finished lubricant can vary a great deal. And we talk about there is that additive health should be monitored through oil analysis. Well, that's true. It's not just the oil health, the additive health that we're looking at. Oil analysis helps us give the overall health of the oil, both the base oil and the additives. It also, oil analysis can give us some information on the equipment. We can see high wear metals, or sometimes we can tell a little bit about the health of the equipment. And if you have a contamination control program in place in your plant, oil analysis certainly gives you an idea of how effective it is. We talked about the different types of additives, and these are the role, what we're trying to improve. We talked about it protecting the metal surface, so that's where some of the wear, anti-wear, and EP and corrosion and rust inhibitors come into place. We talked about it protecting the oil. That's where the antioxidants come in, and the performance to improve the overall performance of the base oil. And we talked about the viscosity improvers. Pour point depressants are just exactly that. If you want to use it, remember how naphthenics will be able to be used at a very low temperature. They have a naturally low pour point. Some of the paraffinics weren't as low. So if we want to increase the pour point of paraffinic oil, we could very easily add a pour point depressant in there. It's not exactly that simple, but there are ways that we could bring it down below what it is. We talked about seal swell agents. Some of the synthetics have a detrimental effect on seals. There's ways to compensate for that when you're blending an oil. And tackifiers, which help the oil stick to metal surfaces. These are a list of many of the different types of additives. We've gone over them. I think they're all pretty self-explanatory. So for the sake of time, we'll keep moving forward. Because this slide talks about not just the additive, but what it does. So an oxygen inhibitor does exactly that. It just slows down the oxidation process. There's various types of chemistry that are used, and it's very common. It's used in most lubricant formulations. Rust inhibitors. They say it absorbs on the metal surfaces, and there's an analogy where they have these little heads, and the head kind of likes to stick on the metal, and the tail waves way, and it keeps the water from attacking the surfaces. So there's various types of corrosion inhibitors that can be used. Those are very common. Both the rust and corrosion inhibitors are very common in many finished products. Anti-wear, almost all oils, with some circulating and turbine oils don't have a lot of anti-wear, but many of them do. Whether it's an engine oil or a hydraulic oil, it's going to have typically some level of anti-wear agent in it. The next step after anti-wear is EP, and many of you will have gearboxes in your plant that will require EP, which stands for extreme pressure oils in them. They're used very commonly on heavily loaded and many reduction gearboxes. There are viscosity improvers and pour point depressants we've touched on. Demulsifiers is exactly what it sounds like. They can be used, as some of you may know, some steam turbines have a tendency, if there's a problem with the hydrogen seal, you can get water into the turbine oil. You want to be able to extract that water very quickly so it doesn't wipe a bearing or cause other damage. So you could add a demulsifier. Anti-foam agents, they're used in various amounts in numerous formulations. There's very little benefit of foam in a lubricating oil. So in the hydraulic system, I think you can all appreciate, if you've ever seen one where the foam and, the foam's coming out the top, that's severe. If it's a mobile piece of equipment, it can cause those controls to get a little bit soft in higher temperatures as it gets air entrained in there. So anti-foam agents are pretty common. Oiliness agent, these used to be used quite a bit in compounded fluids. Compounded fluids were used in what we called worm gears at the time. It's still in use today. There's synthetics that can be used in worm gears, but that's what we mean when we talk about an oiliness agent. Dispersants, detergent dispersants are both part of engine oils. They do just exactly that. If you've ever changed the oil or looked at the oil in your dipstick, you see that over time it becomes dark. As it oxidizes and things go on with the breakdown of the additive and the oil, you don't want those. You want to try to keep those in suspension. So as those particles are formed, first of all, the dispersant keeps them from joining a bunch of little ones into a bigger particle because they can cause bigger problems. So it helps keep them separated, and then a detergent helps keep those metal surfaces clean. Friction modifiers are used in transmission, some in engine oils, but I think of them as primarily used in transmission fluids. Talk about the what's in a grease, right? The grease. So as you can see from the slide, it has the base oil and the additive, but in addition, we add a thickener to the grease, or the grease contains a thickener, maybe more properly stated. It's a nice picture of some grease on a bearing. What's the definition of a grease? Solid to semi-solid product of a thickening agent in a liquid lubricant. The oil and the additive have a lot of influence over the behavior of the grease, but also so does that thickening agent, and we're going to talk about it. The purpose of a grease is pretty much the same as an oil, where it's used to keep two surfaces from rubbing up against each other, causing friction and wear. This gives us a good overview. Remember how we talked about in an oil that, it can vary from, I'm going to use 1 to 20% additive and the rest of it base stock. Well, here it's similar, right? You have, in a grease, the base stock is still makes up a majority of the product. And that's important because it's the oil that's doing your lubricating, right? You want to have a lot of oil in your grease because as that oil is released from the grease, that's what's lubricating that part. The rest of it, additives, we've gone through that. It enhances the ability, and remember how we had various things that we could achieve with additives. We're doing the same thing when we build the grease. We're looking at the base stock versus the application, trying to optimize the performance. But we also add the thickener, and that's the new part in here. And thickener, as you can see, can vary from 3% up to 30% of the finished product can be thickener. Once again, 30% is on the high end, but it's certainly possible. So when we look at the thickener, there's different types of thickeners. There's There's metal soaps and complex metal soaps. There's a lot of different metals that can be used. There's also non-soap thickeners, and we're going to take a brief look at some of those today. Well, a good way to describe the thickener and its function is to think of it as a sponge. The picture below the sponge on the right there is the picture of the grease through a scanning electron microscope, and you can see how that oil kind of gets trapped in those fibers or in those pores, and that's what happens. And then the oil is released typically due to heat or motion or something in there. But that oil is that fiber there is that sponge that's holding the oil in place until the oil is released when we're ready, you know, when as it's worked and stuff, it's released over time. Some of the common thickeners are lithium, lithium and lithium complexes. Lithium greases in general constitute probably almost 70% of the worldwide market of greases made today are in that lithium and lithium complex. Calciums are not as common as they used to be, but there's still a lot of them out there. There's polyurea and bentone. That's some examples of a non-soap type grease thickener. Some of the other thickeners that are used are not as common as the lithium is the sodium, aluminum, barium, silica, Teflon. There's a lot of unique greases made for specific applications that can be very expensive. We're certainly not going to cover all those today, but we wanted to give you a little bit. In a slide earlier, we talked about the straight soap or single and then a complex soap. So just know that that a straight soap, the process that when you put a metal acid, a fatty acid, and a metal hydroxide together to make that process is called sponification. So that when you do that, you get a straight lithium grease, right? Well, there's also a lithium complex grease. So that is put through a secondary reaction down here at the bottom, where you take that, you do a diacid and a metal, you get a complex soap. And when you do that, you increase the dropping point and the shear stability. So in general, we would expect a lithium complex to have a much higher dropping point. Much higher means 100 to 140 F. Higher dropping point than a straight lithium. And it also the shear stability, meaning that when the two surfaces rub together, how quickly that grease softens is typically better with a complex soap. So in your tougher applications, you're barely likely to be looking at a complex metal grease as opposed to a straight soap thickener grease. Some others are polyureas. They're used a great deal in electric motors in today's world. They have very good oxidation resistance. And since there's not a lot of wear that typically occurs in electric motors, they're ideal for that. Clay or bentone, and it's exactly what it sounds like. It's a clay. The benefit of a clay-based grease is that oil doesn't release at higher temperatures. When you look at a technical data for most greases, it's going to have a dropping point on it. The dropping point can be pretty high. It could be 450 to 550 degrees F. That doesn't mean the grease can go that far high, but that's under no mechanical shear. That's the temperature that first drop of grease comes out is the dropping point. That first drop of oil comes, that's the dropping point. Clay bentone greases do not give up their grease just due to high temp. So they're used, clay greases are frequently used at higher temperatures. A little bit on the grease manufacturing process. We talked about the simple soap where you take the metal, remember, you get sponification, and you get the soap and you get the water. A complex is just that, where you do it and you react it twice, right? So that's why you get that double bond. Chemists are not going to, it's not a double bond, but to just an engineer, it's a double bond. And that's why it can go to a higher temperature. Just as base fluids don't always, one isn't compatible with another base fluid, the same is true with grease. Not all grease thickeners are compatible with other grease thickeners. And you want to be familiar or consult with your lubrication experts when you're changing from one grease to another. You should know if the two greases are compatible, and if they're not, you need to come up with a program to purge that grease out as it works over time, so you can get it out of there. Typically, the incompatibility between two greases will lead to a softening of the grease. So, you know, if you've been using, well, let's look at a clay base, right? About clay being high temperature. If you notice that you've never had problems with grease running out of the bearing, and you always use a lithium complex grease, and someday you walk by there and it's running out, and you see the guy and he's going away and he just greased it with your high temperature grease, that may be the reason. Because the clay grease, I don't know if you can see my clicker, but it's about halfway down on the left-hand column, is not compatible with any other grease, and it's certainly not compatible with a lithium complex. So we wanted to alert you to the fact that grease thickeners are not necessarily all compatible. And there are a lot of resources that you could consult to check that compatibility. So you should do that in advance of learning it. Some of the benefits of a grease over an oil is the start-stop, right? Grease remains on the component. I don't know if any of you come from applications where there's big open gears, like ball mills, grinding gears, or cement kilns, or sugarcane. All those have big open gears on them. Well, they are very typically lubricated with a grease or a very highly engineered fluid that almost operates like a grease, because you start them and you stop them. Well, you don't want that big gear to start without lubricant on it. So once it's greased, that grease is going to stay in place, not run off over time. It has good film lubrication. It stays in place under vertical loads, right? So think about a shaft. If it's a vertical shaft, that grease is going to help stay in place. It's a good sealing agent. If you put the grease in the center, right, most bearings are lubricated from the center, and that grease moves to the outside. As it's moving to the outside, it's purging some of the grease and oil or the dirt and the water out of that. Remove the contaminants away from the two surfaces, which is a good thing. You've got grease, and you can have a lot of them. These have reservoirs on bearings where you have excess grease in there, and it comes out over time. We've talked about the contamination. Greases are more prone to be able to keep solid additives in suspension. Moly, graphite, sometimes on extreme loads or shock loading, you want to have solid additives, and they can be suspended in the grease much easier than in an oil, of course. And it can be done on the run. It used to be very commonplace to lubricate equipment while it was operating. I don't know that we encourage that. That's got to be done, but the proper guards and safety precautions have to be taken into account. Frequently, what's happening now is the grease hose is being remounted, 2 foot away. There's a hose that goes into where the grease zert was. You go up, you put grease zert in one end of the hose, and it's pushing the grease into there, so the safety does not create a problem. The safety concern is not an issue. The disadvantages of grease, I think the first one is the one that I think of. Grease tends to hold the heat in place, right? A lot of, think about sumps, and, there's reasons that we use fluids where we use fluids and greases where we use greases. Any hydraulic areas or something like that, they typically are getting high. We want to be able to cool those surfaces and take that heat away from that bearing back to a reservoir to cool off. There's a base oil viscosity in greases, and if you're in a very high speed application, you really want to understand what grease should be best put in there. Contamination control, we talked about the grease purging them out of in a bearing, but the opposite is also true, right? If you get contamination in a grease, if it's not being purged out, it's staying in there. Lower resistance to oxidation, that's true because it is, sometimes they're operating at a higher temperature, so they're not going to stand up as long. Volume control, very little science is being used for a lot of plants about how much and how the equipment is being lubed. It's being done that way because it's always been done that way. I actually think this is an opportunity for many people to go in, look at the application, and put a little bit of some routines and some procedures around that sort of thing to improve it. Talked about the compatibility of it, lack of uniformity. If you're not buying grease from a reputable grease manufacturer, certainly the quality of that incoming grease can vary. Grease manufacturing is not, it's more complex than making a fluid. Not as many people make their own greases or make their own fluids. You certainly want to be buying grease from somebody that you have confidence in their manufacturing process. And for storage stability, I actually think that grease can typically be stored as long as most fluids under the right conditions. Grease consistency. This is an extremely important slide. When most people think about a grease, they're thinking about this number 2 right here. That's what a majority of the greases used are. If you're using an auto lube system, you may be using a number 1 that's a little bit softer. So 1 and 2 are common. They go all the way from number 3, a triple aught, on up to a number 6, which is like very hard. Cheddar cheese, it used to be block grease is what we used to call it. This oil, the triple aughts, I see used in gearboxes, sometimes overhead conveyors and certain things where the seals are shot in the gearbox, but it's kind of a hassle to get that gearbox down and change it. You got to keep it running, but you got to keep oil in there. Well, you put the ISO 220 or 320 oil in there, the seal's shot, so it leaks right out. Sometimes you can use one of these types of greases in there, not indefinitely, but it'll get you through until you're able to get those seals changed out. There are certain gearboxes that are designed for it. Note this number on the bottom, this 445 to 475. This is the penetration in tenths of a millimeter. So as think of it as a weight that gets dropped into a cup of grease, and how far that weight penetrates in is how we determine the NLGI grade of the grease. So obviously that weight penetrates much further into a soft grease than it would into what we call a normal, or certainly into a hard. But this gives you a good idea of the range of greases. As I said, most of us are going to operate in this number 1 to number 2 range for many of the applications. where are some of these lubricants used? Well, everywhere that two metal surfaces can or do come in contact with each other, right? They're used in bearings, in gearboxes, on slides, on electric motors, gearboxes, hydraulic systems, automotive turbines, food-grade equipment use them. So let's recap a little bit of what we've covered today. We talked about fluids. What are the additives? What are the base oils? What are the different types of base oils that can be used in fluids? And then what are the additives that can be used in fluids? We then transferred over and talked about greases. Greases have the same base stocks. We have the same variety of base stocks to choose from. Similar additives, right? We're trying to achieve the same thing. That the manufacturer, the type of additives, the numbers may vary a little bit, but we're still trying to add oxidation resistance or wear or things of that nature. Foaming isn't maybe as big an issue, but you can see where there's overlap between the additives of the lubricant fluids and of the greases that are the same. And then in addition, we talked about the thickener and the different thickener types. And we talked real briefly about the type of compositions for the different lubricants. So we appreciate your time this afternoon. If you have questions, please write them down and send them in, and we'll get them answered and get them back to you. Thank you very much for your time.
All right, great. Well, thank you so much for your time and awesome presentation today. We really enjoyed having you. And on behalf of the entire team here at CBM Connect, thank you to our wonderful audience for joining us today as well. Again, as a reminder, the recorded version of this webinar will be made available on CBM Connect, and you'll receive it in an email tomorrow as well. Then you can see a full list of upcoming webinars and other educational content, some of which is created by the team at Lubrication Engineers on CBM Connect, which you can visit at cbmconnect.com. And then if you're interested in learning any more about Mobius Connect, whether it be the live events or online educational resources, you can visit mobiusconnect.com or follow us on social media at Mobius Institute. And if you have any questions at all, you can email me directly at paige.hattie@mobiusinstitute.com. Thanks again, everyone, for joining us. Have a great day, and we will see you next time.